Hi everyone, this is an example of how to calculate the critical path for a project. Remember that the idea is to understand what is the duration of the project. As part of the schedule management knowledge area, we have 6 processes. Process number 1, plan schedule management. Then we have to define the activities. Then we need to understand what is the relationship between activities, or what are the dependencies. So that's why we need to understand sequence, activities, process. Then as soon as you have the activities and the sequence, you are ready to estimate the activities durations. And for that process, we saw 3 techniques of how to estimate the duration. We saw analogous estimating, parametric estimating, and 3-point estimating. That was part of the last session last week. When we are developing the schedule, the most important thing here is create the schedule baseline, which is the document or the artifact that we will need in order to control the project. And also, if we need to change anything in that schedule, we need to be submitting the change request to the change control board. So we are going to need approval. So remember the 3 baselines that we spoke on integration management: scope, schedule, and scope, schedule, and cost. And last but not least, the last process is controlling the schedule. Today, the example, it's part of the process number 5, which is developing the schedule. I would like to provide some definitions before we move to the example, to the exercise. And the first concept that I would like to present is the PDM. The PDM, it's a scheduling technique. It's the schedule network diagramming technique, in which the activities are represented by boxes or nodes. The schedule activities are graphically linked by one or more logical relationships to show what? It's just to show the sequence in which the activities are to be performed. And I think we presented several examples last week, and also that was part of the team activity, the breakout rooms. So this is an example of a PDM. This chart is representing a project with 6 activities. We have the activity A, activity C, activity D. If I ask you what is the relationship between activity B and activity E, the answer is that you cannot start the activity E as in Edward until you finish the activity B as in boy. So here is 2 things that we are representing right now. We are representing the activities and the relationship. What is this? It's a PDM. It's a PDM. It's a precedence diagram method. We are using PDM. In order for us to move forward understanding the critical path methodology, remember that we have 4 types of dependencies. We have finish to start, finish to finish, start to start, and start to finish. Why I'm providing the 4 dependencies is because for the exam, you need to understand the concept of the relationships. However, for the critical path exercise on the exam, we need only the finish to start relationship. So I'm providing the definition of every single relationship. However, we need to apply only the first one, which is finish to start. And one more time, these are the techniques and concepts that we need to understand before we execute the exercise or the example that I'm providing today. So the PDN, it's a diagramming methodology. We know that. The CPM, it's another technique, which is the one that we will be explaining today using an example. So the CPM is another technique that combined with the PDM, we will be able to calculate two things for the project. We will be able to calculate the project duration and also the total float or slack. What is that, Lisa? Thank you for asking. So first of all, the critical path methodology or technique, it's an analysis that we do in order to determine the amount of scheduling flexibility, which is the float for the logical networks paths in the project schedule network. And also the critical path methodology or technique is used to determine the minimum total project duration. So two things that we are defining using the CPM. Number one, the total duration of the project and also the amount of float or slack of the project. So by definition, the critical path, it's the sequence of the activities that determines the duration of the project. At the same time, as part of this definition, is the longest path through the network. It's the shortest time in completing all the activities in the project. And also, last but not least, very important for the critical path definition, the activities on the critical path have a zero or negative float. One more time, what is the float? Float is the same as slack and is the amount of time that we can delay any activity without delaying the final completion of the project. So the critical, slack or float, it's an asset, it's a resource. And it's for you, it's a good thing because you will be able to make smart decisions when you are executing the activities of the project regarding which activities I can delay. So the total float or the total slack, which is the same concept, is the same, they're synonyms. The total amount of time, as I mentioned before, that an activity can be delayed without delaying the end date of the project. The terms float and slack mean the same thing. So I think we are ready to move forward and understanding now the calculations, the formulas, and the numbers, which is the most exciting part of this exercise. In order for us to calculate the project duration and the total float of each activities, we will be using the early schedule and also the late schedule. So what is this, Lisette? This is a representation of every single activity in the network. So as part of this exercise, we need to understand what is the early start, what is the early finish, what is the late start, and what is the late finish for each activity. The letter A is the name of the activity, and X is the activity duration. So I think we will be providing a better explanation using the exercise coming up. The formula to calculate the float, it's late start minus early start. Also, you can use the other formula, which is the same. It's supposed to be to to create the same result. Late finish minus early finish. These are the formulas that you can use to calculate the float for each activity. In order for us to move forward, we need to understand that the CPM, which is the critical path methodology, uses the forward pass and the backward pass. So let's see in a very practical way how we can understand this much better. This is the type of questions that you may find on the CAPM exam. This is a given information, and they will provide the activities, the name of the activities, the activity durations, and also the logical relationship between them. For example, in this case, we have 4 activities: activity A, activity B, activity C, and activity D. The activity A and activity C, they can start right away. So you don't need to think deep, like this is so deep. It's very straightforward and very simple concept. We have that activity and activity C, they don't have any predecessors. However, the activity B cannot start until activity A and C are finished. And also the activity D can start after activity C is finished. So this is the diagram that we are looking for right now. Before I show you the diagram, just like an reminder, the critical path methodology uses 4 steps to calculate the project duration and the total flow. Number 1, forward pass. Number 2, backward pass. Number 3, total float. Number 4, identify critical path. Let's do it. So the step number 1 is the forward pass. Remember, in order for us to complete the step number 1, we need to define for each activity the early schedule, which is the early start and the early finish. So for activity A, the duration is 5 days. We can start right away. So that's why the early start is 0, because the information we are receiving from the exam, from the question, is that activities A and activity C, they can start right away. So the early finish of activity A, it's the early start, which is 0, plus the duration, which is 5. So the early finish of activity A, it's 5. Let's move forward. For activity C is the same. Early start, it's 0, plus duration is 2. So the early finish is 0 plus 2, 2. For the activity B, it's a little bit more complex because we have two early finish before the activity B can start. So in this case, the rule is that for the forward pass, you need to select the maximum amount, the biggest number. So in this case, what will be the early start of activity B? Will be 5 or 2? Yes, we need to select the 5. Why? Because we are performing the forward pass right now. So if you know that the duration of activity B is 2 days, what is the early finish of activity B? Same procedure that we implemented on activity A and C. So 5, which is the early start, plus duration, which is 2, it's 7. So for the activity D is the same, but this one, the activity D, it's more simple than the activity B because in order for us to define the activity B, early start and early finish, we had to make a decision between 5 or 2. Now it's just one possibility, which is 2. So what is the early start of the activity D as in David? There's only one possibility, which is 2. So if you want to know what is the early finish of activity D, the only thing you have to do is just add the early start plus the duration. So it's 2, which is the early start of activity D, plus 6, which is the duration. Okay, listen, who is providing the duration? The exam. Who's providing the duration of the activity? The question that I already put it on the previous page. So what is the early start of activity N? It's 7 or 8? It's 8. Why? Because we are doing the forward pass. Now we have completed the step number 1. Moving to the step number 2, we can, at this point, we are able to answer the following questions. What is the early start of activity B? The early start of activity B is 5. What is the early finish of activity C as in Charlie? Early finish of activity C is 2. So why I'm just putting these 2 questions as part of the exercise before we finish is because for the exam, at this point, you don't need to do anything else if you see this type of questions regarding the early start or early finish. Why? Because you are right now calculating the forward pass. So if you want to continue with the step number 2 is the backward pass, we will be doing the same, but from the right to the left. And now instead of adding the duration, we will be subtracting the duration for each activity. So let's do it. For activity B and activity V, the late finish is 8. Why? Because we don't have another option. We have only one option, which is 8. So for activity D, it's 8. Now, what is the late start of activity D? It's 8 minus 6, which is 2. The same way we are ready to calculate the late finish and the late start of activity B as in boy. So what is the late finish of activity B? Is 8. And the duration is 2. So 8 minus 2 is 6. Let me just put it this way. So now we have the activity B with the 4 parameters we are looking for. So it's the late finish is 8 minus 2 is 6. So let's move forward. Remember, this is subtracting the duration and also selecting the minimum value from the right side to the left. Now, activity A. Remember that in activity A, you don't have any problem to make the decision because you have only one possibility from B to A. So what is the late finish of activity A? Is 6. So what is the late start of activity A? Is 6 minus 5, which is 1. Now, how can we calculate the late schedule of activity C as in Charlie, which is the next one? Remember that now we have 2 options, 2 late starts, and we need to select which one, 6 or 2. Remember, we are doing the backward pass. In this case, the rule is to select the minimum, the shortest the smallest value between 6 and 2, which is 2. Thank you so much. So the late finish of activity C is not 6, it's 2. Why? Because we are performing the backward pass. So what is the late start of activity C? Simple, it's 2 minus 2, which is 0. Now, if in the exam you see this type of questions, you will be able to answer as soon as you complete the backward pass. So what is the late start? These are the questions for the exam. What is the late start of activity C, as in Charlie? What late start is? 0. What is the late finish of activity D? The late finish of activity D is 8. So Liz said, why are you doing just 2 questions? It's because this is an example. So you can have a different questions, but these are the 2 questions that are, you can have another question, for example, what is the late start of activity A or B instead of C or D? So this is just randomly created. Okay, now that we complete the step number 2, we are ready to move to the step number 3. Step number 3, it's total flow. Calculate the total flow. By definition, or the formula to calculate the float, the total float for each activity is just simple transaction. It's a simple operation. It's just subtracting late finish minus early finish. That is simple. So for activity A, the total float is 6 minus 1. I'm sorry, 6 minus 5, which is 1. For activity B, the total float is 8 minus 7, which is 1. For activity C, it's 2 minus 2, which is 0. For activity D, is 8 minus 8. So having said that, I am able now to move forward and provide the values for each activity. So for activity A, it's 1. For activity B, it's 1. For activity C, is 0. For activity D, it's 0. So this question, now we're ready to answer this question. What is the total float of activity C? 0. What is the total float of activity A? A as an apple. 1. You see? What is the total float of activity B? It's 1. And by definition, the critical path, the activities that are part of activity, they are part of critical path, they have a float, total float equals 0. So now, from now, you can visualize the future. So the critical path, the activities on the critical path, it's start C and D. So let's see. Now that we understand what is the total float for each activity, we are ready to determine the critical path. So for this network, for this project, the critical path, I'm going to put it in red color, which is C and D. Start, C, D, and end. So remember, the critical path is the longest path in the network, and also is the shortest time that you can finish all the activities of the project. So this is, I think this is the example that I prepared for you to be able to watch this video before the class on Saturday. Please let me know if you have any questions, and I talk to you on Saturday. Have a wonderful rest of the week.